Hey guys, it's me, Miss Rash. I'm going to be teaching your science class via video. So the substitute will be playing this video for you when it's time for a science class, and she will be pausing and playing the video throughout the class whenever you need to pause to discuss or to pause to work. So the first thing we're going to do, if your substitute hasn't already passed out your classwork, go ahead and pause the video and do that now. Your classwork is a page that looks like this. It says periodic table of elements at the top. Once you have your work in front of you, you may pause the video, set the timer for 5 minutes, and allow students to work. Okay. Now that you've had 5 minutes to work, let's go ahead and review the answers. The first question, what are valence electrons and what do they tell you about an atom? Valence electrons are the electrons that are found in the outermost energy level. So if you have a valence electron, it's going to be in the very outside energy shell. Valence electrons determine reactivity. So if you do not have that written, you can go ahead and write that now. Let me pull it up to help you guys out. Valence electrons located on the outermost energy level. They determine reactivity. And second question, what is the atomic mass of an element with 5 protons, 6 neutrons, and 8 electrons? To determine the atomic mass, you need to add the protons and the neutrons. So we're not doing anything with the electrons because electrons are so small that they barely have any mass. So all you have to add are the protons and neutrons, which would make the atomic mass of this element 11 atomic mass units. Now we're going to go ahead and jump into our review of some information that we learned yesterday. So if you have your notes from yesterday, you can feel free to take them out to assist you with this. Otherwise, teacher, please pause this video and set the timer for 5 minutes. Students, turn and talk and answer these 3 questions. First, where are valence electrons located on an atom? We kind of already gave that answer away in the do now. Second, why are they more important than the other electrons? And third, what happens when an atom is happy, stable, or non-reactive? You have 5 minutes to turn and talk. Substitute, go ahead and pause this video. All right, substitute, you can feel free to call on students to share out the answers to this. Otherwise, I'll go ahead and give the answers. Where are valence electrons located on an atom? They are located in the outermost energy level, the very, very outside of the atom. Why are they more important than the other electrons? Valence electrons are the most important because they determine reactivity. So whether or not an atom is going to bond with another atom is going to depend on the valence electrons that it has. So if it has a full shell of valence electrons, that would mean it has 8. That would mean that it's not very reactive. That would be a stable atom. So that goes into the third question. What determines when an atom is happy, stable, or non-reactive? That would mean it needs to have a full shell of valence electrons, so all 8. If it does not have 8 valence electrons, that means it is a reactive atom, and it will attempt to bond with other atoms until it can become stable with those 8 valence electrons. The next thing we're going to do is watch a short video about the periodic table of elements. While this video is playing, you should be at voice level 0. You should not have any materials in your hands. Your eyes should be on the screen. Again, our voices are at level 0. You cannot talk and listen at the same time. Let's watch.
Dear Tim and Moby.
Dear Tim and Moby,
Please make a movie about
the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way up to atomic number 118, but any element above 92, uranium, is too unstable to occur in nature and has to be made in a lab.
All right, I'm going to pause the video there. And let's go back to our key points. So these key points aren't exactly the same as you see on your paper, but they go over the same information. So anytime you see key points in a lesson, guys, that means these are the things that are most important for you to remember when you leave class today. So these are the things that you're going to need to know to pass your exit ticket. First, the periods are the rows on the periodic table. They go from left to right. All of the elements in the same period have the same number of energy levels. So they have the same number of those electron shells. Remember, the valence electrons are going to go in the very last shell, the outer shell. Groups are the columns that go up and down on the periodic table, and elements that are in the same group have similar chemical properties and reactivity. Remember, reactivity is determined by the number of valence electrons. If there are 8 valence electrons, that atom is stable, it is non-reactive. If an atom has less than 8 valence electrons, that means it is chemically reactive. So all of the elements that are in the same column going up and down have the same number of valence electrons. So they have similar properties, including their reactivity. Now, in the periodic table, you probably notice it's organized by numbers. The number is called the atomic number, and it is equal to the number of protons that an element has. So if you look on your periodic table, that's at the very, very back of this packet, you see an example periodic table. Element number 6, carbon, has 6 protons. Element number 9, fluorine, has 9 protons. So whatever the atomic number of the atom is, that is the same amount of protons that that atom has. Now, let's get into our daily model. Let me see if I can move this screen so you guys can see it a little bit better. There we go. Hopefully you guys can see this okay. You should be following along on your paper where it says daily model. All of the words that are underlined, like you see here, the words that are underlined should be copied into your notes. So as I'm going through this slide, you're going to be copying in your notes. So for our daily model, as you can see, like we talked about in the key points, the periods are the rows going across left to right, and the groups are the columns going up and down. So this periodic table, it contains all natural, meaning they occur in the real world, and synthetic, meaning they are made in a lab. It contains all of those elements. The periodic table is arranged by atomic number. So you'll see the first period at the top only includes hydrogen and helium, element number 1 and 2. Then when you go down to the next group, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and so on, all of those elements in the same period, they have the same number of energy levels. All of the columns going straight up and down, those have the same number of valence electrons. So all of these elements here in the first group, they have only 1 valence electron. All of the elements over here all the way to the right, those have all 8 valence electrons. So in group 18 over here on the side, starting with helium, that group is stable. All of those elements are stable because they have all 8 valence electrons. So main thing to remember here, the periods are the rows growing across. So there is 1, 2, 3, 4, 5, 6, 7 periods. And the groups are the columns going up and down. So those you can see with the number at the top. 1, 2, 3, all the way over to 18. Now, before we get into our independent work, I want us to pause for a moment and review some information we learned yesterday about valence electrons. So I'll give you a moment to review this diagram. We'll notice over here, lithium has only 1 valence electron in its outer shell, and fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Remember, for it to be full, it only needs 8 valence electrons total. So lithium is going to give 1 of its electrons over to fluorine so that fluorine has a full shell of 8 valence electrons. So question, why doesn't fluorine transfer all 7 of its electrons over to lithium? Answer is, it takes way more energy to transfer 7 electrons than it does to transfer only 1. So whenever an element only has 7 valence electrons, it will usually bond with another atom that has an electron to give to it so that it can become a full shell of 8 valence electrons. Okay, now you guys are going to get into your partner practice. You'll be working on this for 10 minutes. Teacher, please pass out the reading. It should be 1 page. They can get all of the answers for their partner practice from that reading. After the 10 minutes is up, you can move on to your independent work on the next page. You will use your periodic table for that. And after you are done with your independent work, make sure, it says here at the very top, before you answer, label the columns and periods on your periodic table. So you're going to need to use this periodic table at the back of your paper. Let me make this bigger. There we go. You're going to need, oh, why is it blurry? Okay, not sure why it's blurry in the video, but I'll just show you guys. This is the periodic table that you should have on the back of your packet here. Now, this periodic table is in color. The one that you have hasn't been printed in color. But before you do your independent work, you're going to want to go ahead and label the top as your periods. Go left to right. And then over here, you're going to want to label your, oops. Let me just delete this one. You're going to want to label your columns over here on the side. Columns go up and down. Well, now I'm messing up, but I'm sure you guys know what I mean. So after you label the columns and the periods in your periodic table, you should be able to complete all of these independent practice questions. Sub, you can go ahead and pause this video and you can give the students 10 minutes to complete their independent practice. It shouldn't take you longer than 10 minutes to complete this because you can find all of the answers in your periodic table. So for number 1, it says, what are 2 elements in period 4? In order to figure this out, I'm going to need to go back to my periodic table. I know the periods, according to my notes, it says that the periods are the rows that go from left to right. So these are my periods. Here's period 1 going across, period 2, period 3, and period 4. So all of these elements, 19, 20, 21, 22, 23, this whole row of elements are all in period 4. So for my answer to this question, what are 2 elements in period 4? I can write potassium. I could write calcium. I could write any of those elements. So if you see me looking down, I'm just looking back at my periodic table to help me out, which is what you guys should be doing as you go through your independent work. Now, the last 15 minutes of class are going to be spent completing your exit ticket. Your exit ticket will be going in the grade book. It is for a grade, okay? So I'll be grading your exit tickets and putting those grades in the grade book. You have the last 15 minutes of class to work on the exit ticket. Good luck.